Okay, hello students of class 10, and I hope you are doing well. So today we are doing physics, and we will do our chapter 3, that is work, energy and power. And in this chapter we learn the various concept of work, energy and power, and this is very important chapter, so you have to learn this chapter very carefully. Okay, so we'll start our topics one by one. First we'll learn about work and its concepts, and then energy, and followed by power. Okay, so first we'll do work. Okay, so this work, okay, these are very simple, you have to understand, and then you will not have any difficulty. Okay, work is suppose there is an object, suppose this is a box. Okay, and we are applying force on this box. Okay, a person is applying force on this object, on this box. So if this box moves from this position A to suppose at this position B, the same box but now position change, it moves this much distance. Okay, so due to this force, this object, this body, this box moves from A to B. So then there are two things, means first one, we applied force and then object moves. Okay, so the work is, it is defined from these two concepts only, that when we apply force, or when an object or when a body apply force on any other object, okay, and object moves. When you apply force and object moves, or we can say object displays, okay, then it is said to be work done. Okay, it is said to be work done. So means there are two conditions necessary for work done, that first of all we must apply force, and second, that object should move. Okay, these are two essential conditions for work done. So another way we can say that when a force acting on a body produce displacement. This is the general definition of work done, that when we are applying force on a body and it produce displacement on that body, then it is said to be work done. Okay, so the formula for work done will be work equals to force into displacement. Okay, this is the general formula, work equals to F into S. So this S stand for displacement. So this is the general formula of work done, work equals to F into S, force into displacement. Okay, and what are the two essential conditions? That first one, there should be force applied on the body, and second condition, that object should move, it should displace. So these are two essential conditions. Okay, and then there are some cases. Okay, I'll show you here in your book also. Okay, so there is one more formula for this. We'll discuss that a little about that, but first of all, it's SI unit. So SI unit of work is joule. Okay, this is SI unit, and sometimes there is also given that we know that SI unit of force is Newton and displacement is meter. So SI unit of work is also Newton meter, and then there is a relation between joule and Newton meter. So we can write 1 joule equals to 1 Newton into 1 meter, or we can say 1 joule equals to 1 Newton meter. So you have to remember this relation also, that 1 joule equals to 1 Newton meter. Okay, and then when the second case means when we are applying force on an object, For example, you might have seen that carry bag which have wheels on its ends. Okay, so suppose this is that bag. I'm just showing a simple diagram, and from this end, okay, we apply force. So we apply force in this direction. For example, the direction of force means we are applying force in this direction. We generally apply force on this direction, upward direction. We pull that bag upward direction, and then the displacement happen in this direction. Okay, so the direction of force is here, but the body is moving in this direction. The displacement is happening in this direction. Okay, so here in this case there is projection. There came projection between the displacement and the direction of force applied. Okay, so here means what happened, if I will simplify this diagram, means we are applying force here, but the object is moving here in this direction. The direction of force is here and the displacement is happening in this direction. Okay, so there is angle between these two terms, force and displacement. Okay, so then the work done means we will define work done by taking this theta also, this angle also. Okay, so in this case work done will be you have to remember this formula only. Okay, in exam it do not ask derivation, but this is the formula for work done. In this case, that work done will be force into displacement, and we will take cos theta here. So theta may vary, theta can be 0, 30, 45, 25, whatever. Okay, so we will take in term of cos theta. So you have to remember this formula. Okay, if angle is given, so we will use this formula, that work equals to force into displacement and cos theta. Okay, so this is also very important. So theta here is the angle between the direction of displacement and that of force. Okay, so this theta is the angle between direction of displacement and direction of force. So you have to remember this formula. Okay, so now from here there occurs few cases, so we will learn them one by one. So case number 1, okay, these are case for work. I'll show you here. Okay, case 1, when theta is 0. Okay, theta is 0 means work is happening in the direction of force applied, or the body is moving when the displacement is in the direction of force. Means suppose we apply force here in this direction, and the body is also, suppose same example, the box, we are applying force on this box, and this box is moving in the same direction. So in this case theta is 0. Okay, so first case, when theta equals to 0 degree. Okay, so we will put this theta in the formula. So we know that work equals to force into displacement into cos theta. So here theta is 0, so work will be force into displacement into cos 0. So we know that cos 0 is 1. Okay, the value of cos 0 is 1. So here the work will be force into displacement into 1, which will be force into displacement. Means in this case the maximum work will be done. Okay, because this totally depends upon these two values, force and displacement. Okay, so whatever the value of force will be and displacement will be, that will be work done. So in this case there will be maximum work. So this is also a condition of maximum work. Okay, remember this thing. And then second case, when theta is 0. So the case second is when theta equals to 90 degree. 0 we have done. So when theta equals to 90. Okay, theta 90 means the angle between force. Suppose we apply force here in this direction and body is moving here, or we are applying force in here and our body is moving here. Okay, both cases. So you can see the angle between the force and displacement is 90 degree. Okay, so in this case what will happen, so we will put the value of theta in that formula. So work equals to force into displacement into cos 90. Cos theta is here 90, and we know that cos 90 equals to 0. Okay, so here work will be 0 because 0 will be multiplied with this, so work will be 0. Means in this case there will be no work will be done in this case when theta is 90. Okay, so there are few examples, as earth is revolving around sun. So suppose this is sun and this is earth. So if the case occur that suppose earth reaches here, so direction between the angle, direction of motion and the force, because sun is attracting with gravitational force and this is direction of motion. Okay, so suppose the earth is rotating here, so you can see the angle is 90, so work done will be 0 in this case. Okay, so and another example is given in your book also. I'll explain. A person